One of these robots is going to change the world, and whoever wins this race gets to control the future of work, manufacturing, and even how we live our daily lives. The question is, will it be the Tesla Optimus or the XPENG Iron? Today, I'm breaking down these robots across 7 categories: design philosophy, movement, intelligence, deployment, manufacturing, ecosystem, and global market access. The aim is to find out which is the best, because what I've found researching this might completely flip everything you thought you knew about humanoids.
We designed a structure that's more like a real human spine.
Let's begin with the most fundamental question. What are these robots even trying to be? Tesla Optimus stands 5 feet 8, weighing 125 pounds, and it looks like a robot on purpose. It has exposed mechanical joints, black and white industrial colors, and Musk wants it to handle dangerous, repetitive, boring tasks, not pretending to be your friend. That's a very deliberate American approach to robotics. XPENG Iron, on the other hand, takes the complete opposite approach. Standing 5 feet 10 with soft synthetic skin covering its entire body, a 3D curved display face, this feels very different from anything Western companies are building. Because of how realistic XPENG's movement is, people genuinely thought there was a human hiding inside the suit when it was first unveiled.
We've always wanted our robot to feel familiar.
The company literally had to cut open the robot on stage to prove it was actually a machine. So you've got America saying keep robots obviously robotic, while China is saying make them as human as possible. Round 1 goes to Tesla. But having a clear purpose means nothing if your robot can't actually move through the real world. And this next category, it's not even close. This round matters more than people realize, because our entire world is built for human bodies. Staircases, doorknobs, uneven sidewalks. Tesla Optimus has 28 degrees of freedom in its body and 22 inches, the newest hands. They just showed it jogging this past December, which was a big milestone, but it still moves like a robot learning to be human. XPENG Iron has 82 degrees of freedom total, with a bionic spine mimicking human vertebrae, plus synthetic muscles that stretch and contract. They train to walk based on thousands of hours of actual human footage. The difference is obvious. Iron is designed to move and work in spaces humans usually occupy, while the Optimus is best suited for the factory floor. So, round 2 goes to XPENG for dramatically more fluid, natural movement. We're tied at 1-1. But a robot's body is just hardware. What really matters is the brain running inside it. And this is where one of these companies has a secret weapon that almost nobody is talking about. Tesla Optimus runs on the same neural network powering their full self-driving system. That means millions of Tesla cars on the road are collecting data that makes Optimus smarter every single day. That's a massive hidden advantage most people don't think about.
It'll take time. I think there's certain threshold breakthroughs that we think we can achieve.
XPENG Iron, on the other hand, uses 3 AI models working together, running on proprietary chips with 2,250 TOPS of computing power. Sounds impressive, but here's the thing. Tesla's AI has been battle tested in the real world for years, while XPENG's system is newer and less proven. When you're building a robot that might work in your house or handle dangerous factory tasks, you want the AI that's seen more edge cases. Round 3 goes to Tesla for the more mature, battle-tested AI stack. Tesla takes the lead 2-1. But now we separate the hype from reality, because the real question is, are these robots actually working anywhere right now? Tesla has a pilot production line at Fremont, and Musk keeps promising thousands of robots in factories by the end of 2026.
You said recently tens of billions of robots, but that's decades away.
At least 1 decade away.
But independent reports say they've actually built hundreds, not thousands. XPENG, however, has a partnership with Chinese steel giant Baoshan for equipment monitoring and plans to deploy in retail stores by late 2026. But here's where it gets interesting. XPENG's own CEO admitted that factory work isn't viable yet because the robot's hands wear out in about a month. That honesty is refreshing, but it shows how early stage this technology really is. So, it's fair to say round 4 is a draw because neither company has deployed at a real scale yet. Tesla leads 3-2. Okay, stop for a second. If you've made it this far, you probably know where this is going. Tesla's ahead, American innovation wins, roll credits. But the next 3 rounds are where this whole thing flips, because rounds 5, 6, and 7 are about who actually controls the robot supply chain, who has the real data advantage, and the geopolitical nightmare nobody wants to discuss. This is the stuff that made me completely rethink who's going to win this race. Stay with me, because the picture gets uncomfortable fast. Okay, this is where things get scary because China is flexing hard and most people have no idea how dominant they already are. Tesla has massive plans, converting their Fremont production line to robot manufacturing, building a dedicated Giga Texas facility targeting 10 million units per year by 2027 with prices between $20,000 and $30,000 per unit. Sounds amazing. But here's the problem. China controls approximately 70% of the entire humanoid robot supply chain. All those motors, sensors, actuators, and batteries that every single robot needs, including Tesla's, are mostly coming from Chinese manufacturers. And it gets worse because Chinese companies like Unitree are already selling humanoid robots for as low as $6,000. Manufacturing costs across the industry dropped by 40% in just 1 year.
China sells working robots for 1/10 of that price.
That collapse in cost happened largely because of China's supply chain dominance. While Tesla might have bigger ambitions and louder announcements, XPENG and Chinese companies have massive structural advantages in actually making these things cheaply at scale. That should genuinely worry anyone paying attention to this race. Round 5 goes to XPENG for supply chain control and aggressive cost advantages. We're dead even at 3-3. And right now, you might be thinking, China has this locked up. Cheaper manufacturing, supply chain dominance, they're unstoppable. But there's one hidden advantage Tesla has that could change everything, and most analysts are completely missing it. This is the hidden advantage most people overlook. Tesla isn't just building a robot, they're building an entire ecosystem. Optimus shares its brain with every Tesla car on the road, and that data flywheel is incredibly powerful. The same AI learning from millions of vehicles is improving Optimus simultaneously. Plus, Tesla makes their own chips. Their upcoming AI 5 chip is supposed to be 50 times more powerful than the current generation. XPENG, on the other hand, has a strong EV business, but their global footprint is way smaller. They just don't have the same massive data collection network spanning multiple continents. Robots get smarter through data, and Tesla has more connected devices collecting more information worldwide. Because of that, round 6 goes to Tesla for an unmatched ecosystem and global data collection. Score is now Tesla 3.5, XPENG 2.5. Tesla pulls ahead 4-3. 1 round left, and this final category could decide who controls the future of the entire world. It doesn't matter how good your robot is if countries won't actually let you sell it. XPENG has a massive problem here because Chinese tech is facing increasing restrictions in Western markets. We've already seen what happened with Huawei getting banned, TikTok facing legislation, and DJI drones getting restricted. So, would America, Europe, or Japan allow Chinese humanoid robots into their hospitals, factories, and living rooms? Think about this for a second. A humanoid robot in your home sees everything you do, hears every conversation, and processes all of that data somewhere. With tensions between the US and China at historic levels, this isn't just about tech, it's a matter of national security. Meanwhile, Tesla is an American company with factories in the US, Germany, and even China. That gives them way less political friction when selling into Western markets. Yes, Elon Musk is controversial and polarizing, but the company itself isn't sanctioned or banned anywhere. China's domestic market alone is massive, with 1.4 billion people, and Chinese companies already dominate there. But if you combine the US, Europe, Japan, and their allies, that's an even bigger total market. And because of that, round 7 goes to Tesla for global market access and international trust. Final score, Tesla. 5, XPENG 3. Tesla wins. Case closed, right? Not even close. Because here's what the scoreboard doesn't tell you. Chinese companies are ahead in actual deployment right now, shipping 80% of global robots while most of the world wasn't paying attention. Meanwhile, Tesla is ahead in AI maturity, ecosystem integration, and positioning for the long game. The stakes here are genuinely terrifying. By 2050, there could be 1 billion humanoid robots in use globally. Whoever wins this race doesn't just sell machines, they gain leverage over the entire future of work, manufacturing, and daily life itself. This isn't Tesla versus XPENG anymore. This is America versus China battling for control of the next industrial revolution. And the winner? They won't just sell robots. They'll decide who works, who doesn't, and what work even means for the next century. The race started years ago. Most people just didn't notice. Now you do. The question is, what happens next? Tesla and XPENG fight over your living room. Other companies are building robots designed for war. And what they unveiled at UMEX Abu Dhabi should genuinely concern you. Click the next video to find out more.